this is a continuation of the previous example. I kind of stopped in the middle. So we'll continue from this problem. So now let's see how many integers from 1 to 999 have at least one repeated digit. All right, so if you think of this as like have one at least one repeated digit, so think of these numbers as like repeated, at least one repeated, right? At least one repeated versus no repetition, that with no repeated digit. So they make up, these two subsets make up the total, all these integers. So therefore, we can actually use the difference rule that introduced earlier. We already found this answer. There are 738 number of integers that have no repeated digits, right? So and the total 999 numbers over there. So therefore, at least one repeated digit, we just find the difference. So therefore, this count is equal to the total, which is 999, minus, and this count, which is 738, found above. Therefore, we have 261 numbers that have at least one repeated digit. Now to close this section, the last example is, what is the probability that an integer chosen at random from 1 to 999 has at least one repeated digit? Basically, what's the chance of getting a number from this 261? So we just use 261 divided by total number, which is 999 numbers. And this number is divisible by 9. This is divisible by 9 because the sum of these three digits is equal to 9, definitely divisible by 9. So let's cancel the 9, divide by 9, we have 2 and then 18 minus, that's 81, 29. The bottom is 111, so 29 over 111. All right, let's move on to the next example. In a certain state, license plates consist of from 0 to 3 letters, followed by 0 to 4 digits. By the way, a blank plate is not allowed. You cannot say I do not want to use letter and do not use digits. That will be a blank state, a blank plate that won't be allowed. So let's count how many different license plates can the state produce. All right, so we definitely think about this as two-step process, right? The first step, let's form the letter part, and then second step, form the digit part. So because we talk about step-by-step process, you want to multiply the result from these two separate steps. So step 1, we talk about the letter, we form the letter. And because you can have from 0 to 3 letters, so you can have 0 letter, so 0 letter. How many ways that you form a result that does not have any, like 0 letter, no letter? Only one way, you just don't pick any, right? So it's just one way, one result. What about one letter? Just form a plate that with only one letter, because we have 26 letters, so 26. And 2 letters. And what do you think? So pause the video and think about it. And it will be 26 square, right? 26 times 26. 26 for the first letter, 26 ways for the second letter. So 3 letter, you have 26 cubed. So total, you're going to have, so the total of those possible from 0 to 3 letters, it will be 1 plus 26 square plus 26 cubed. And this is equal to, if you remember, 1 minus 26 to the power 1 more than this 3, right? Which is 4. 1 minus 26. This turns out to be 18,279. So double check that for me. So this is just step 1. Now step 2, you want to form step 2, the numbers, right? The numbers. And you can choose from 0 to 4 digits numbers. So when you have 0 digit, only one way, you just don't choose any 0. And then 1 digit, you have 10 ways, right? Because 0 to 9. 2 digit, 10 square, hopefully, and 3 digit, 10 cubed. 4 digits, 10 to the power 4. If you add this together, so 1 plus 10 plus 10 to the 4th, this will be pretty easy to calculate. It's just going to be 11111, right? This will be 10,000, 1,000, and so on and so forth. Or you can still use this formula. You can, for the practice purpose, you can do 1 minus 10 to the power 5, and then 1 minus 10, and then you should get the same answer. So because we have two-step process, the process we have to add, multiply these two together. So therefore, the total will be, you multiply these two together, 18,279 times 11111. However, keep in mind, blank plate is not allowed. That means this combination is not allowed. Only this combination is not allowed. You cannot say 0 letter and 0 digits. So therefore, we have to subtract that special case. This is a blank plate, right? So therefore, my algebra turns out to be 203,097,968 number of plates. Now, suppose 85 letter combinations are not allowed because of the potential for giving offense. How many different license plates can the states produce? In other words, from here there are 85 letter combinations that should not be used. Numbers are still okay. So how do we find count? So you can certainly, so in your step 1, right? Just quick update. In your step 1, this you should minus those 85 words, right? 85 words. So therefore you have 18,279 minus 85. So exclude those 85 from all those possible combinations, and then times the 11,111. And of course, don't forget to subtract 1 because that's the blank plate scenario. So this, I believe it turns out to be 202,153,534 number of plates. Alright, this is it for this video. In a separate video, we're going to introduce the very last, the last 2 rules of this section, and then do a couple more exercises.